Hello everyone. Welcome to the solution of LeetCode problem 1368 named minimum cost to make at least one valid path in a graph or in a grid. In this problem, we are given a two-directional grid. Each cell of the grid has a sign pointing to the next cell you should visit if you are currently in the cell. And here, the sign is 1, that means you can visit right. The sign is 2, that means you can visit left. And for the sign 3 and 4, you can visit lower and upper cell. Now, notice that there could be some signs on the cell of the grid that points outside the grid. Now, you initially start at the upper left corner, which is 0, 0. And a valid path in the grid is the path that starts from the upper left cell and ends at the bottom right cell, following the sign of the grid. The valid path does not have to be shortest. Now, you can modify the sign on a cell with cost equal to 1. Now, you can modify the sign on a cell one time only. That means one cell can be modified only one times. Now, you have to return the minimum cost to make the grid which have at least one valid path. Now, let's consider this example. Here, the directions are something like this. Now, I hope you understood the problem statement. I will explain these examples in the next algorithm section. Here, to understand the algorithm, we have taken the same example. Now, currently we are presented at this position 0. Let's make the thickness very deeper. And now our goal is to reach into this cell. Now, this is the direction. So we can go into the right direction. Now, if we flip this direction to downwards, then we can go into these directions. Now again, if we flip this into downwards, we can go into this direction. Now again, if we shift into the downwards, then by using this path, we can easily go to the destination cell. So here, what is the minimum number of flips we have to perform? It is 3. So this is the problem statement. Now, I hope you understand it. Now let's see how can we solve this problem. Here, if you first understand correctly, is that this is a basically 0-1 BFS problem. Why so? Because suppose currently we are presented at this cell. So this cell we can directly go to its right cell. Okay. So if we take a DQ to process the 0-1 BFS, we can store the right cell into the front side of the DQ. And here, by using one flip, we can go up, down, and left. So this up, down, and left will be inserted into the DQ into the back side. That means, suppose for any of the cell, we will try to reach the immediate cell, which we can reach directly by using this cell, which is the right one. Afterwards, it can be possible that it is not the optimal solution. So we have to flip the sign. So if we flip the sign, we have to insert the other direction into the left position of the DQ. That means while we processing the DQ, we will start the processing into the front side. So here, the directly going cell will be processed first and modified cell or the cell we can reach if we modify the sign will be processed after. Now, This problem basically can be solved using the traditional DFS. The intuition is very simple. We will store or we will start the iteration from the starting cell, and we will store its direction cell into the front side of the DQ and into its flipped cell, or we can flip the sign to reach those cell. We can easily insert this into the left side of the DQ. Now, by doing so, we will maintain a two-directional array or two-dimensional array cost, which will store the minimum cost of each cell. If we want to reach respective cell from the starting cell, and after completing the BFS, we will print the bottom right corner of the first cell. I hope you understood the algorithm. Now let's move on to the code. Here, we are given a function named minimum cost, which has a two-directional grid. Now, we have integer n and m. Now, we are taking a cost array, which is a two-directional also. Now, we are taking a DQ of pairs. Now, we are taking the directional array and we are inserting the current starting position into the DQ and initializing the cost of the current starting position with 0. Now, while the DQ is not empty, we are storing the front element of the DQ into a current element. This is the BFS. And here, the coordinate x and y is being calculated. After that, we have to remove the front element of the DQ. Now, we have to iterate into 4 of its direction. And we have to calculate the new x and new y. And if the new x or new y becomes out of bound, we have to continue. Otherwise, the new cost will be cost of parent, which is xy, plus grid of xy not equal to I plus 1. And here, if the grid of xy is not equal to I plus 1, 1 will be added, otherwise 0 will be added. Now here, if the new cost is less than cost of new x, new y. So here we have to store the new cost to the cost of new x, new y. And here we have to insert the new direction or new cell into the front or back side of the DQ. So here, if the grid of xy is equal to y, we have to insert new x and new y into the front side of the DQ. Otherwise, we have to store them into the back side of the DQ. Finally, we have to return the cost of n minus 1 and m minus 1. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.